Welcome to the Project Risk Management Masterclass. Upon successful completion of this class, you can earn one PDU by the Project Management Research Institute. Top 5 project failures. So let us start with, in order to appreciate the project risk management, let us take a look at the top 5 project failures that better risk management could have avoided. One is the Fukushima nuclear disaster. It happened in 2011. The loss is 235 billion plus life loss. The risk failure, the tsunami hazard underestimated, inadequate contingency planning. So actually, what happened was they planned for a high tide or the waves hitting the nuclear reactor. But in this particular instance, what happened was the waves came and hit the reactor along with the floating containers. And the project management team did not anticipate that. And that resulted in the 235 billion loss plus the human lives. Then another example is the Chernobyl disaster, 1986. Again, $235 billion loss. Risk failure, unsafe testing, poor governance, ignored operational risk. Then we have the Bhopal gas tragedy, which happened in India in the year 1984. 10 billion plus many lives, lot of people lost their life. And the main issue there was poor maintenance. That was an inadequate safety systems and ineffective emergency planning. That was the issue. And the Union Carbide had to close their operations in this area, plus compensation to the victims. A lot of people, life was affected. So that was a major tragedy. Then we have the Space Shuttle Columbia, which happened in the year 2003. We had the great Indian origin astronaut also losing her life, 13 billion loss. The risk failure, form strike risk accepted despite previous incidents. So people forecasted this. Such a tragedy can happen when it enters the Earth's hemisphere from outer space. There is a risk kind of which people ignored, and that resulted in the tragedy. What is the key lesson? Projects rarely fail because risk exists. Project fail because the risks are underestimated or not managed proactively. Now, global statistics on construction project losses due to poor risk management. Uh, project Projects meeting the cost and schedule targets is only 8.5 percentage. That means 90 plus percentage is according to this standard. They are not meeting the cost and the schedule targets. An average cost overrun in large infrastructure project is a whopping 80 percentage cost overrun. Can you imagine it? It is very high. And average schedule delay is 50 percentage. That is also very, very high. And then we have mega projects experiencing cost overruns or delays. 98 percentage of the mega projects, they have cost overruns and delays. And we have project value lost due to poor risk management is US dollar 1.5 trillion. Then we have projects exceeding budget. 9 out of 10 projects exceed the budget, and average infrastructure cost overruns by sector in the railway segment, 44.7 percentage have cost overruns, and bridges and tunnels, 33.8 percentage, and roads 20.4 percentage. That is average infrastructure cost overruns by sector. And then we have infrastructure projects with cost overruns. 86 percentage of the projects have cost overruns. Then average benefit shortfall, that is 69 percentage of the projects doesn't meet the initial benefit forecast, for which using which the projects were justified. And then we have claims and disputes impact 5 to 15 percentage. So it is not a very rosy picture. Only 8.5 percentage of the projects are meeting on time within budget criteria, and 80 percentage of the projects average cost overrun is 80 percentage. That is very high. I think this gives you the impact or the potential for better risk management. We could have avoided many of these things, or we could have reduced the impacts by proactive risk management. The top 10 construction risk, we have the safety incidents as the major one. Safety incidents, then schedule delays, cost overruns, labor shortages and productivity issues, material supply chain disruptions, design errors and scope changes, weather and natural events, equipment failure or unavailability of equipments on time. Hence, the resources have to wait for the equipments. Then regulatory and permit delays. There is a major delay in EPC projects, and stakeholder and contractual disputes. So that also contributes to construction project risk. Then if you take 10 IT project risk, security breaches is a major concern. Schedule delays is another thing. Scope creep, resource shortage, and skill gaps, and requirements changes and volatility of the requirements, technical complexity and integration issues, and data quality and migration issues, vendor or third party failure, environment and infrastructure issues, and stakeholder alignment and communication. So these are the major risks with the top 10 IT risk. And then we have the top 10 AI project risk here. Here, poor data quality is a main risk for AI projects, and inadequate training data. So either data is not available or the quality of the data is bad, which results in inadequate training data. Then model hallucinations and incorrect outputs. The reliability factor of the outputs is a concern, and data privacy and security breaches, unclear business requirements, wrong use cases, AI biases and ethical issues, integration with legacy systems, lack of skilled AI resources, regulatory and compliance changes. Since AI is fast emerging, the regulatory and the compliance areas are not well defined yet, so they are also evolving. So the amount of change that happening in that segment is very high. Cost overruns, cloud, GPU, LLM, APIs, then user adoption and change resistance. So these are the top 10 AI project risk. I brought in all these things to show you uh, the potential for professional risk management in various category of projects. Now let us get into the master class objective. The only objective of this class is to impart insights to manage project risk more effectively. So if you can get some points from this class, and if you can take it back to your workspace, and you practice them. And because of that, if the project success rates improves, that is the best dividend this training can have, and that is the sole objective. And the secondary objectives are, if you want to learn risk management, this is a complete module, and we are referring only to the project management body of knowledge plus our own experience in risk management. So if you're preparing for, if you want to master risk management according to the project management body of knowledge, uh, you can be 100 percentage guaranteed that whatever we are saying is according to the project management body of knowledge. A risk is an uncertain future event or condition that, if it occurs, can positively or negatively affect the project objectives. So it is a uncertain event which can happen in the future, and if that happens, it can affect the project positively or negatively. So here, one key thing here is a risk need not be always negative. There are positive risks as well. That means if you're trying to deliver if your expectation is, okay, let us say 25,000 users will enroll in the first phase of the project, and suddenly there is a demand for 100,000 users coming in, and that is a positive thing. But if the product cannot scale to that level, and if you're unable to leverage that opportunity, then that opportunity is lost. So that is an example of a positive risk. Now let us take a look, try to understand the difference between a risk and a issue. A risk is uncertain. It may happen. An issue means it has already happened. That is a fundamental difference. And risk is uncertain. Issue is 100% certain because it has happened, and requires proactive management, whereas an issue requires immediate resolution. Maybe it's reactive in nature. It has already happened, so we cannot wait. Uh, for example, a supplier may delay delivery, so we can. It's a futuristic event. Here, supplier has already delayed the delivery, so we have to get into reactive mode or firefighting mode. Risk has two elements, that is the probability and impact. The probability of the risk happening, and if it happens, what is the impact on the project? So put together, that is the risk. If the probability is zero, there is no risk. If the impact is zero, there is no risk. This is the process flow for risk management. First, we have to identify the risk. We start with the risk identification, and we create a risk register, which will contain the list of risk with some classification. Then, on the risk register, we perform qualitative risk analysis. That means against each risk, we associate a probability number and an impact number, and we multiply the probability number with the impact number. Sometimes we give a weightage for difficulty in detection. So you multiply these three factors, and we prioritize based on that number. That is the first level of risk prioritization based on probability and impact. Then we do a qualitative risk prioritize qualitative analysis happens here at step 3, and risk for we do the risk prioritization based on the probability, impact, difficulty in detection, and urgency. And if it is something, probability may be low, impact can be high, and it is very urgent. It must be done immediately, otherwise it will become an issue. Then it may get a higher priority. And whatever is filtered out from step number 4, that undergoes quantitative risk analysis. Here we use techniques like Monte Carlo analysis, uh, decision trees, sensitivity analysis, etc. Then, for the shortlisted risk, we come out with the risk response planning. When we say response, the action we take to reduce the probability or impact or both. So that is the risk response planning. We are not implementing; we are just planning it. Then contingency planning. That means if the risk happens really, what are we going to do? For example, designing an earthquake resistant building will be a risk response planning. But defining what need to be done if an earthquake happens, that is the contingency planning. And both involves additional cost and additional time. Then we get into monitoring and controlling, monitor and control risk triggers. So when is it going to happen? Is it going to happen immediately? What is the current status of the risk? Is it crossing the threshold? So we have to monitor constantly the risk threshold, because certain risk at times the probability can be very high, the impact also can be very high, and when if that is crossing the threshold defined for the project, then we have to trigger action. Uh, and and after 8, we have to initiate the risk response actions and contingencies. If the risk is crossing the threshold or about to cross, it is a it must be monitored very closely, and we may have to initiate the risk response actions and the contingency actions. Step number 10, monitor and control effectiveness of the risk responses. So we may initiate risk response action and contingency actions, but again, we have to monitor the effectiveness part of it. Then update the risk register and actions. That is a constant process. So we had the risk register happening in the beginning. At that level, the amount of data that gets into the risk register is very low. But at this level, at step 11 level, we have more information about the risk. We have the probabilities, impacts, contingency action, uh, response action, status of these actions, who is the owner. Everything gets added to the risk register. So it is an updated risk register we have here, which acts as a communication tool as well. At step number 12, we communicate the risk statuses, and we report the status, communicate and report. We may use the updated risk register for it. So this is the workflow of the project risk management process, and it is continuous in nature. This has to happen continuously, because risk identification is not a one-time activity. This has to happen throughout the project, because new risks will arise as the project progresses, and the risk register need to be updated. So this is a continuous process within the project. Risk identification, that is the first process in the risk management process flow. Inputs could be the project charter. We already have the charter, which will have the high level risk, the business risk, high level risk will be listed there. Then we have the project management plan, any component of the project management plan. project documents, especially the assumptions law. So whatever assumptions we have made while planning the project, there there is a good pointer to identify risk. Requirements, documentations, lessons learned register from past projects and maybe from the current project as well. Stakeholder register, agreements signed already. So a review of those agreements can reveal some of the risk. Procurement documentation again can reveal risk. Then enterprise scanning the enterprise environmental factor will give us potential risk. And organizational process assets like historical data, etc. That is also a good input for risk identification. And the tools and techniques we use for risk identification, we have the expert judgment. Experts can give their inputs to identify the risk. Then we may use data gathering techniques like interviews, brainstorming, checklists, questionnaires, and workshops to identify potential risk. Then data analysis like the root cause analysis or the Ishikawa diagram or the fishbone diagram. It's all same. We have already explained these things in the 7QZ tools lesson. Then SWOT analysis. The SWOT SWOT stands for strengths, weaknesses, opportunities, and threats. So if you can do a SWOT analysis of the stakeholders, if you can do a SWOT analysis of the uh, suppliers, if you can do a SWOT analysis of the team members, if you can do a SWOT analysis of the uh, senior management, uh, or if you can do the SWOT analysis of the project itself, that can reveal many risks. Assumption and constraint analysis. We have cases where uh, the soil condition assumption the team made was totally different when they went for the construction, and the impact was a 7 years delay in the project. Then a document analysis. There is a saying like in a scope document, if you cannot write a test case against a particular scope element, then there is a risk. If you take a full WBS work breakdown structure, and if there are some work packages where we cannot write a acceptance criteria, or we are unable to estimate because there are some gray areas in a work package, that is a clean risk. Then a representation of information using cause and effect diagram or Ishikawa diagram. So these are the typical tools and techniques. The output is the risk register. So the step number two, process number two is risk register. Here is a sample risk register. It will have a risk ID number, a risk description, a risk category or source, external, internal, etc. Then the potential cause and the potential event or impact it can have. These columns are not standard. This is just a specimen. We can customize it based on our needs. Uh, and once the risks are identified, then we can categorize the risk. That means some of the categorization criteria are given here. Source-based categorization. That means from where is this risk originating? Is it a requirements-related risk? Is it a design-related risk? Is it a contract-related risk? From where is it coming from? Then a target-based. In case if this risk happens, where is this going to impact? If this risk happen, will it impact the cost? If this risk happen, will it impact the uh, schedule? And event-based risk. When is this risk likely to happen? So a design change can trigger some new risk, or when we fix 10 defects, there is a possibility of injecting a new defect. So it's event based. Then time based. So in which phase of the project? Okay, this is when the risk may occur. Pre-project initiation, planning stage, execution stage, or monitoring and controlling, etc. When is it likely to happen? And then we have other uh, forms of category, other useful categorization. So that is also given here by probability, by impact, by risk ownership, by geography, by complexity, etc. So the risk categorization has an advantage because the moment it is categorized, it is easy to assign to a particular entity or a person or a team with a specific skill set who are specialists in that category of defects. So, but if you have a mix and match of all defects, then it is very difficult. Categorization helps us to focus and maybe even to delegate that particular category of risk to a particular entity or team or an individual. Then let us take a look at the types of risks we have. Uh, so we already said that the risks are uncertain events or conditions that, if they occur, can affect the project objectives. Project risks can be scope related, schedule related, cost related, quality related, resources related, and stakeholders related. Technical risks could be technology failure, design flaws, complexity, performance integration. Then external risk examples could be economic issues, legal and regulatory issues, political issues, political instability, then market issues, etc. Organizational risk, governance, culture, structure, decision making, leadership, and change resistance. One project manager was sharing me things like they had project team members from two different countries where the work styles or work ethics are totally different, and it became very difficult to manage the projects because one particular group, they had the history of working 8 hours every day professionally, Monday to Friday, and weekends and are non-negotiable. They will not work. Whereas another set of people, they're okay to work round the clock without any holidays. So this cultural issue had a major impact for this person to manage that particular project successfully. Risk categories across project lifecycle. We have primary risk, that is inherent risk, the original risk that exists before any response or controls are applied. Example, high probability of supplier delay. That is a primary risk. Secondary risk, a new risk that arises as a result of project activities, changes, or risk responses. As I said earlier, project having defects is a primary risk. Secondary risk is when I when I fix 10 defects, I can inject a new defect. That is a secondary risk. And a residual risk. Nobody ships a product after detecting 100% of the defects in it. Even Six Sigma talks about 98.8 percentage defect containment before releasing the product to the customer. That means some residual risks are getting passed on to the end user. So that is an example of residual risk. I might have detected 98.8 percentage of the defects in it, even if I'm operating at a world-class level. Still, some residual risks are there. Then risk could be, as we discussed earlier, it could be a negative risk or threats, or risk could be positive risk or opportunities. Negative risk, we have to manage them, whereas positive risks, we should leverage them or we should exploit it to the fullest uh, because it is beneficial. And once the risks are identified, classified, grouped, etc., it is a good idea to come out with a risk breakdown structure, RBS. Here is a sample RBS of a construction project. All the project management related risks are grouped here, and technical risks are here, and external risk here, contractual risk, health and safety, environment risk, and financial risk. So, as discussed earlier, this type of grouping will help us to delegate that particular branch to the most competent entity in the organization who are equipped to manage them well. Risk breakdown structure, remember it, RBS. This RBS helps to identify and organize risk by category for comprehensive risk management. Each risk category can be further broken down based on project size, complexity, and specific context. As discussed earlier, so we have this project characteristic. One of the key characteristics of the project is a progressive elaboration nature. The risk register also evolves as the project progresses. Risk information becomes more detailed and more actionable as the project progresses. So during the initiation phase, we have the basic risk register. During planning phase, that has more details, and during execution phase, it contains even more details, like the probability, impact, and action taken, and the status, etc. Then monitoring and controlling, again, we'll get the trend. Trend gets added here. Is it on the upward trend, or is it going horizontally, or is it on a downward trend? Uh, so the risk register also evolves as the project proceeds, project progresses. Then once the risk register is done, then we get into qualitative analysis, qualitative risk analysis. We list down the risk here, potential impact is here. Then for every risk, we associate a probability number and an impact number. So during the planning phase, we would have defined this probability scales and the impact scales. It could be 0.1 to 1, or it could be 1 to 5. So 5 means it is certain. 4 means the probability is very high. 3 means medium. 2 means low. 1 means it is very low. Similarly, impact. 5 means very high impact. 4 means high impact. 3 medium, etc. So for every risk, we associate a probability rating and an impact rating. And we multiply the probability rating with the impact rating, and we get a risk score. That is P into I is the probability into impact is the risk score. So here, the first two gets a 16, and then we have 12, 9, 9, 8, 4, etc. The probability scales examples are given here. Again, this is not a standard. Organization to organization, it may vary. Project to project also, it can vary. But these things must be defined during the planning phase itself. Probability, impact, and the definition of these risk scores or interpretation. 13 to 25 means it is very high. Probability impact is considered as very high, and 7 to 12 high. So these ranges are also defined during the planning stage. So this gives us focus. We can always look at the top. If our risk threshold is, let us say, 10, then we say, well, the first three risks we will manage now. Uh, the yellow color can be under observation, and the green color, for the time being, we need not do anything. So we call this process as a qualitative risk analysis. Then a risk prioritization, because the previous slide also I explained this. So this is we may use a risk rating matrix for prioritizing risk. Here, this very high band, we must take action immediately. This orange band also, immediately we should take action. Yellow band can be under observation, and the green band, for the time being, we can ignore them. We call it as a risk rating matrix. The next is the quantitative risk analysis. So whatever is filtered out from here and prioritized, those risks can undergo a quantitative risk analysis. So inputs, we have all these things. The tools and techniques we use for quantitative risk analysis are, one is the Monte Carlo simulation. Simulates thousands of scenarios to estimate the probability distribution, etc. Then we have the decision tree analysis, expected monetary value, EMV analysis, sensitivity analysis, scheduled risk analysis. All these are tools and techniques we use for quantitative risk analysis. Now, let us take a higher level look at the Monte Carlo analysis, estimating the range of possible outcomes using repeated random simulations. So here you list activities / cost items with uncertain values. So ABC, these are the activities in a project. And here we have the duration in days, but we don't have a definitive estimate for these things. So we come out with three numbers, that is optimistic, most likely, and the pessimistic for these activities which are risky. Then for each simulation, random sampling, for each simulation, randomly pick a value within the range for each activity. So we run the permutations combination for all these for these things, and an output is calculated. An outcome is calculated for each combination, and this steps 2 and 3 are repeated 5,000, 200,000 times, and we get a result out of it. So that is a black box. Unless we are experts in operational research, it is very difficult to explain that. We, as project managers, we should understand what is Monte Carlo analysis. There are tools available to do it. So that is an opportunity for us. And this is the output of this simulation. Distribution of possible outcomes, project duration days. number of simulations, and the project duration days here. So what it says is we have a 50% chance for completing these activities in less than or equal to 13 days. And we have an 80 percentage chance of completing these activities in less than or equal to 14 days. And we have a chance of 95 percentage chance of completing these activities in less than or equal to 15 days. So that is the output of the Monte Carlo analysis. So this is again a simulation technique. Uh, these days, it is people have started using it extensively. Then expected monetary value or EMV of the risk. Uh, for example, EMV is the sum of the products of each outcome's probability and its monetary value, cost or benefit. If you take a risk, the best case probability is 0.20, and if the risk monetary value is let's say plus $50,000, then the expected monetary value of the risk is 0.20 into 50,000, that is 10,000. The most likely case, if the probability is 0.50 and the monetary value is 20,000, then the expected monetary value is zero point 0.5 into 20,000, that is 10,000. And the worst scenario, probability of occurrence is 30.30, and if the risk happens, it has an impact of minus 30,000. So the expected monetary value can become minus 9,000. And if you add up these three, it is 1. And here, if you add up all these, we get 11,000. So the expected monetary value of that risk is 11,000. Okay, then we have the decision tree. This has the application of expected monetary value built into it. So the square box is the decision node. So here we are making a decision here. Launch a new product, option 1. Launch a new product, and option 2 is expand existing product. If a new product is launched, we have a 0.60 probability of high demand and 0.40 probability of low demand. If high demand happens, we'll make a profit of $250,000. If a low demand happens, we'll make a loss of minus 50,000. At the same time, if you expand existing product, probability of high demand is 0.0, and the profit will be 150,000. And the low demand probability is 0.30, and the loss will be minus 20,000. So option 1, the expected monetary value is 0.60 into 250,000 plus 0.40 into 50 minus 50,000. So 130,000 is the expected monetary value of option 1. Similarly, for option 2, the expected monetary value is 0.70 into $150,000 plus 0.30 into minus 20,000. So that is 99,000. So choose option 1, a higher expected monetary value. So this helps us to decide things professionally. So because that is a decision tree. Then sensitivity analysis. We have already explained this when we explained the Monte Carlo analysis. because that is also based on sensitivity analysis. It determines which variables have the greatest impact on the project outcome, cost, duration, or NPV. So in this case, the steps involved for a sensitivity analysis is first you select the variables. So in this case, the variables are sales price, project duration, construction cost, operating cost, and discount rate. Change one variable, vary one variable at a time. Uh, Example, minus 10 percentage to plus 10 percentage while keeping others constant. And recalculate the outcomes and measure the impact, rank the variables. So if we do this multiple iterations, then we say the longer the bar, the greater the impact of that variable on the project outcome. So sales price has a major impact on the project outcome. Project duration has the next higher impact on the project outcome. Construction cost has a next level. So the longer the bar, so focus management attention on variables with the highest impact. So it's an example for a sensitivity analysis. As project managers, we need to understand that such things exist. But if you have to literally implement these things within a project, we can always avail the services of a project management office. They will be able to help us out. Then this is a very common thing that is happening these days in mega projects. Schedule risk analysis. So first thing is you define the schedule, create a baseline schedule, identify uncertainty. So certain activities in the schedule may have a lot of uncertainties. You identify them. Then you go with the 3 point estimate, optimistic, pessimistic, and the most likely for those activities. Then simulate, run many simulations, 5,000 to 100,000. You may use a Monte Carlo analysis to do this. Evaluate the results and interpret and decide. So here, example output, uh, the completion target days less than or equal to 12 days. We have a probability of 20 percentage. Less than or equal to 15 days, we have a probability of 50 percentage. Less than or equal to 18 days, we have a probability of 80 percentage. And less than or equal to 20 days, 90 percentage. And less than or equal to 22 days, 95 percentage. So we will be able to come out with a forecast on what is the confidence level we have to complete that particular sequence of activities in how many days, which will point to schedule risk analysis. Again, as discussed earlier, uh, it is not as easy as just go and implement these things. Uh, we have to literally sit down, brainstorm, plan, and then come out with a prototype with sample data, run it, and perfect it. So we discussed about qualitative risk analysis and then quantitative risk analysis. Now it is about risk response planning. Risk response strategies we have for negative risk, we can avoid that risk or we can mitigate that risk, reduce the probability of occurrence or the impact. Then, or you can transfer the risk. I mean, taking an insurance is a good example of transferring the risk to another entity, or outsourcing a complex piece of work is an example of risk transference. Sometimes we accept that risk. This project is risky. We accept it, no problem. Or escalate it to the next level. And if it is a positive risk or opportunity, we can exploit it. Then next step is contingency planning. Risk response planning we did, and next is contingency planning. Well, contingency planning is the risk is happening, what you're supposed to do. So again, risk identification, risk register, qualitative, blah, blah. Contingency planning is preparing in advance for potential risk. Identify risk, analyze and prioritize, develop contingency response, assign roles and resources, monitor and review. If the risk occurs, do these things. If the risk doesn't occur, continue with the main plan. Uh, I've observed these YouTube videos of earthquakes in Japan. When the earthquake happens, nobody is panicked because everybody's trained. The contingency action is like everybody must be trained and everybody know what to do, and they just follow that procedure. Procedure is defined. It is they are all trained, so the casualties also can be very very low. Then monitor and control risk triggers. See, some organizations have high risk appetite. Some organizations will have very low risk appetites. So we have to monitor and control the risk triggers. For example, a volcano, we know when it is about to erupt. Similarly, every risk there is a threshold. So you have to monitor continuously, track risk indicators, assumptions, and key metrics. Compare, trigger, and act. Here, if you see this diagram, if you see uh, the risk as the probability and impact has reached unacceptable zone, so immediately we have to trigger the response actions and the contingency actions to bring it back. So this is a risk tolerant. Yeah, on the x-axis is the timeline, and the y-axis is the risk exposure. Then initiate risk response and contingencies. We already discussed this: avoid, mitigate, transfer, accept, exploit. So based on the trigger, we initiate these actions. Then we have monitor and control effectiveness of risk responses. That is step number 10. The best tool for this is a risk burn down chart. On the y-axis, we have the cumulative probability into impact of all the risk. And on the x-axis, we have the project duration. And if our risk response actions are effective, over a period of time, the cumulative P into I should reduce. As the project progresses, if the cumulative P into I is on a descending trend, that means our risk response actions are effective. But if it is going horizontally or if it is going up, there is a clean indication that it is not effective. We call it as a risk burn down chart. Then update the risk register and actions. As we discussed, the risk register gets updated continuously. So here it is a more expanded version of the risk register. We started with only a small portion of it at the time of initiation, and during execution stage, a lot of details gets added to it: probability, impact, risk rating, who is a risk owner. So every risk need to be associated with an owner, a response strategy, planned response actions, and residual risk, and current status of the risk. So this is an updated risk register. Then you have to communicate and report the risk status to the key stakeholders and maybe every stakeholder to some extent. We use the risk dashboards. So if you're using project management information systems like Ranch Smart Project, uh, we can have dashboards which will show us all these icons which will represent the current status or the cumulative P into I of the risk. Is it in the danger zone, or is it at acceptable levels? Risk register is there. Then risk heat map, which we already discussed. Uh, Y-axis impact, x-axis probability. So red band must be addressed immediately. Yellow band can be under observation. Green band, no issue there. And I've seen this happening in the smart project by Range Smart Project. If you, it shows this, and if you click on it, you can do drill down analysis. You get the more details about those risks. And organizations may have different templates for risk reporting to different stakeholders, and risk communication and brief updates to the project team. So here we have the audience, risk dashboard for the executive sponsors, steering committee, risk register for project team and risk owners, risk heat map again for project team stakeholders, and risk report sponsors, management representatives, and risk communication brief for the project team and cross-functional teams. This is a RASI chart for risk management. When you say RASI, responsible, who is responsible for it, who is accountable for it, who is consulted, and who is informed. When we say R, who is responsible, who is the person who does the work, who is accountable for it, who owns it, and who must be consulted, who provides input for it, and who is informed, kept up to date. So, plan risk management, the project sponsor is accountable. Again, not a standard from project to project, it can change. Project manager is responsible. Risk manager, some projects, the project manager and the risk manager could be the same. Some projects, they could be different. So, risk manager should be consulted, project team must be consulted, functional managers consulted, subject matter experts consulted, stakeholders that information should go. Then identify risk. Project sponsor must be informed. Project manager is responsible. Risk manager is consulted. Project team is responsible. Subject matter experts responsible. Analyze risk. Project manager is accountable. Risk manager is responsible. So it's a good idea to come out with a classic chart for risk management during the planning phase of the project itself, so that the responsibilities are crystal clear. So we traverse through all the stages of the risk management process workflow. We started with risk identification, then preparation of the risk register, qualitative risk analysis based on probabilities and impact, then risk prioritization uh, based on probability, impact, then that is qualitative risk analysis here, probability, impact, and based on the P into I, we prioritize them. Then quantitative risk analysis. We discuss things like Monte Carlo analysis, sensitivity analysis, schedule risk analysis, etc. Then plan risk response planning, contingency planning, then monitoring and controlling risk triggers, and initiate risk response actions and contingencies, and monitor and control effectiveness of risk responses. We discussed about the application of a burn down chart. Then update the risk register. We saw a fully blown, fully updated risk register, and different modes of communication of the risk status to different stakeholders. We also saw a RASI chart for risk management. This completed the entire risk management process flow in projects. You can convert your learning into a one PDU certificate by the Project Management Research Institute by completing a 10 question assessment. The link to the assessment is provided in the description of this video. So if you want to get that certificate, anyway you spend time, your time, you can complete that 10 question assessment, which is very easy. Then we'll be able to provide you with a one PDU certificate. The link is provided in the description of the video for the quiz. You just complete it. So thank you, and we will be coming out with more master classes like this. To stay updated, you will subscribe to the channel if you have not done yet. Thank you very much.